Welcome to this course on data warehousing. Myself, Navneet Goel, and I'll be I've divided this course into several modules, and I'll start off with the first module, that is introduction, which is again split over two presentations. So I hope to cover the first presentation in the first video. Right. So this is the course. So initially, I'll talk about the kind of books and references that I'll be referring to in this course. So the main books are Paul Raj Punia, then Kimball. All right, Kimball is that's a book that we'll use mainly for the modeling part. Then we have Anna Hori and Dennis. So that will be on that's another standard book on data warehousing. And then we have Kimball and Reeves and et al. So that is basically on the warehouse toolkit. And then we have another one, another book by Inmon, so building the data warehouse. And this book, like Kimball and Inmon, are kind of they propose kind of different approaches to data warehousing. So I'll be covering both of them, but mainly focusing on the Kimball's approach. And then we have a data warehouse design solutions book by Adamson. So that also I'll be referring from time to time. And before I proceed, there was a very recent development on as far as the world's largest data warehouse is concerned. So as you might be aware that the data warehousing technology emerged in the early 90s, and Walmart was one of the first or early adopters of this technology. So now this largest data warehouse is at SAP in conjunction with NetApp, so it's a storage company, and several other partners at SAP Intel data center in Santa Clara, California. So this is a huge setup, and the amount of data that is typically there is 12 petabytes, and which is addressable storage, and it's a kind of a Guinness World Record. And it is based on SAP's HANA in-memory data platform, and it also is built on SAP IQ, that is a solution for data warehousing from Sybase, and BMM Soft and Federated EDMT. So, and it uses NetApp SAN storage solutions. And just for your interest, it contains more than 221 trillion transactional records. So that is huge, and more than 100 billion unstructured documents, including emails, messages, and images, right? And it also contains data from 30 billion sources, including users, smart sensors, and mobile devices. So it's a very interesting, I would say, case study if you are interested in data warehousing, right? And I would strongly recommend that you look at, go to the site and look at what actually is there inside this world's largest data warehouse. I'll keep coming back to this from time to time, as and when I need to discuss this. And I'll also, as we go along, I'll also be talking about the technologies that are used. I'll give you some inputs on that as well. And there's an article that you can read, An Insider's View into the World's Largest Data Warehouse by Larry Freeman of NetApp. So this article is available on the net, so you can just refer to it. So let me start by giving you some background and how this concept of data warehousing emerged and evolved over a period of time. So it basically started in the 80s to early 90s. Data warehousing concept started in early 1990s, but in the 80s and the early 90s, the focus was mainly on computerizing the business processes, right? And this was mainly done to gain some kind of competitive advantage over your competitors, right? So, for example, if you were to open an account, a bank account, and if you have two options, and the first option or the first bank gives you says that it has a fully computerized office, a branch, right, and the other one is doing it the traditional way, right, you will definitely be more impressed by the bank that is fully computerized, right. So in those days, this gave you some kind of competitive advantage over your rivals, right. By early 1990s, say mostly all the companies had operational systems. That means all of them had kind of computerized their operations, and yeah, and this computerization did not offer any kind of advantage in the early 1990s. I'm again referring to the developed countries here, right? Not necessarily in India and the third world countries, right? So now the question came up. Now the new question came up, like how do we get competitive advantage over our rivals when all of them have an operational system in place? So, so before I answer that question, let me tell you a little bit about operational systems and what are their primary purposes, right? So it is also called as online transaction processing systems, OLTP systems, and they basically run the operations of the business. So for example, banks, railway reservations, etc. And it is based on ER data modeling. So I'm sure you've done a course on databases. So you would be familiar with ER modeling, right? Entity relationship modeling, and it is a transaction-based system, and the data is always current valued, and little historical data is available, right? Say a few months or maybe few days, depending upon the kind of business you are in, and data is highly volatile. Volatile in the sense that it keeps on changing. Say, for example, if you look at a bank database, right? So a lot of people would be doing business with the bank, right? So, say somebody is withdrawing money, somebody is depositing money, somebody is transferring money. So all those kinds of transactions are happening at a very brisk rate. So that's why the data would be highly volatile. That is, data values will keep on changing. They keep on changing very, very quickly. And operational systems typically have intelligent keys. Say, for example, if you look at a typical ID number of a BIT student, so it has a lot of information embedded into it. Like, say, if I take an example, say 2000, so I'll just write it here. Say 2014 A7 PS 102P. So that's a typical ID number of a student in bits. So, and that is a particular, that's a key for a student, right? So what happens here is that this ID number has a lot of information embedded into it. Like 2014, it tells me about the year of admission of the student. A7 tells me the discipline, which here turns out to be computer science. And then PS stands for practice school option, which is there by default. And 102 is basically the merit position of the student in the admission process, right? And P stands for the campus, that is Pilani, right? So you can see so much of information is built into this particular key, right? So that's why we say intelligent keys. On the contrary, if you just say a student is identified by 1 or 2, any integer, then this number 1 does not convey or tell me anything about the student. So that's the difference. So that's why we call this ID number. So ID number of students in bits is a typical. It's an intelligent key. And further details on the operational systems. So it has a rational normalized design. So I'm sure all of you are familiar with the normalization process, right? So the design is typically normalized because as we know that there are too many updates to be carried out. So if it is not normalized, the updates are going to take very, very long, right? And redundant data is undesirable, right? So in operational systems, we try to do away with redundant data. So redundant data is typically is not a good thing as far as operational systems are concerned, right? So I'll talk about redundancy in much more detail as we go along, right? And it consists of many tables. So there will be a good number of tables in your operational systems which will have data about the different entities and the kind of relationships that exist between those entities. And one typical characteristic of OLTP systems is that high volume retrieval is inefficient. So because they have not been designed for that purpose. So they have been designed for narrow queries. Narrow queries like, say, if I say, okay, tell me what is the balance in this particular account. So I just input the account number and the balance will be shown, right? So they are optimized for such repetitive queries and common data in many applications. So if you look at typical university setup, right? So there will be many departments or divisions which will have the same data. Like for example, so suppose there is an IT department in a university, right? So it will have data about what all students are there, what is their ID number. So they are responsible for generating the email IDs of students and also about the net access of the students, right? On the other hand, there will be a student welfare division, which is typically there in almost all universities, right? So this would also have student details, right? Similarly, there will be other divisions which there will be a timetable division, right? So which will also need data about students, right? So the student data is there in many applications. So that is a typical scenario. Now let me just give you some idea about the need for data warehousing. So companies over the years, right, have gathered huge volumes of data, right? So using their operational systems. So what does this mean? This means that, so suppose there are millions of customers with a bank, and all of them are doing transactions with the bank or doing business with the bank, like in terms of withdrawing money, depositing money, or any other kind of transaction. So each and every transaction that they carry out is recorded. So that's why we say that companies over the years, like banks, have gathered huge volumes of data. Similarly, if you look at a company like Walmart, right? So every transaction or every sale is recorded, right? So you just imagine how much data they would have with them, right? So this data is actually nothing but a hidden treasure, right? Initially, when the companies started computerizing their business, so they had a worry that what will they do with this data that is being collected, right? And later they tried to kind of see this data as an advantage, right, or as a kind of a treasure, right? So can this data be used in any way, right? So these were the kind of questions that people started asking. And can we analyze this data to get any competitive advantage? So I left that question earlier in the lecture, that how to get competitive advantage over your competitors, right? So the answer is here. So the answer is data warehousing. So basically what you want to do is you want to analyze this data that you have collected over the years and see if there are any kind of information, right, that I can collect or that I can find out from this data and use it for my advantage, right? So I'll give you specific examples in this slide. So data warehousing is typically, so let me just see if So data warehousing basically gives you a lot of benefits. It's a framework that allows you efficient analysis of data. So I'll also be talking about what I mean by analysis, right? Okay, as in the next few slides. And it provides you with competitive advantage because I know something that my rivals do not know, right? And analysis aids strategic decision making. So this analysis, the results of these analysis are typically used for strategic decision making, right? And it increases productivity of decision makers because the data that they need for decision making is made available to them, right, through the data warehouse, and they can do whatever analysis they want to carry out. And it has a potential high ROI, that is return on investment. What this means is that so whatever you invested in the data warehouse, right? So there is a typically you will be able to recover that cost very quickly using a warehouse, right? And there are certain classic examples like diaper and beer, and more recently there is something about polo shirts and Barbie dolls. So let me elaborate on although first one is a very classic example, but let me elaborate on the second one, polo shirts and Barbie dolls. So a store like Walmart or some chain of store found out that there was a very high incidence of people buying polo shirts and Barbie dolls together, right? So the management was not very sure why this kind of pattern has emerged, right? Or why there is this correlation between sale of polo shirts and Barbie dolls. So when they looked into their warehouses for answers, and when they analyzed this data, they found out that the persons who were buying these polo shirts were married men, and they had a little daughter in their house, right? So what how they could analyze this is that these polo shirts. So these polo shirts are very expensive shirts, right? So when they bought polo shirts for themselves, so they felt guilty, right, that they're buying something so expensive for themselves. So they decided that they'll pick up Barbie dolls for their daughter, right? And this is how these two things were selling together, right? And there was a very high incidence of that. It is not just one or two sporadic cases, but uh, thousands and thousands of men were doing that. So it was a kind of an interesting pattern that could be unearthed, right? Mainly because we had collected huge volumes of data, sales data for these grocery stores. So, and I would want you to find out about what is the story behind diapers and beers so that you can figure out on your own, right? So that is also very interesting, but somehow you should try to find out and read about it. So let me now give you some connect between decision support systems, data warehousing, and OLAP. So basically, a data warehouse is a decision support system. It's not an intelligence system or an expert system. So it is basically a kind of a repository of data where you collect data or bring data together from various sources. These sources could be external sources, and typically they are internal sources of data, like the operational systems that the organizations have, right? So it's a decision support system, right? And online analytical processing is a kind of a tool that sits on top of a data warehouse and allows you to do analysis, right? And the analysis is typically very, very complicated or complex, and it is not very intuitive for users to be writing these complex queries using SQL, right? And I'm right now assuming that we are working on top of relational databases. So your data warehouse is implemented on a relational platform, right? So this OLAP tool allows even novice users to kind of specify very complicated queries which can be run against the data warehouse. So this is the kind of connection. So data warehouse is an OLAP. Data warehouse is a decision support system, and OLAP is a tool, is an analysis tool. So OLAP stands for Online Analytical Processing. So when this data warehousing technology was emerging, people started asking questions about why we need a separate data warehouse. Why can't we just use the operational system to run some complicated queries? So why we separate out? It is mainly because of performance, and there are certain other reasons. So you can and the function that the features that are provided by a data warehouse. So let me elaborate on each one of them. So performance, operational databases are designed and tuned for known transactions and workloads. And typically the kind of analysis that you do on top of a data warehouse, right, they are typically ad hoc, right? So I don't know what kind of analysis I would do, right, or any other user of the data warehouse would do. So you don't know the kind of workloads. So the operational systems have been designed, right, and tuned for known transactions or known workloads, right? So if I run these OLAP complex OLAP queries, right, so that would degrade the performance of operational transactions, right? So that's why we want to separate them out. And special data organization, access, and implementation methods needed for multidimensional views and queries. So multidimensional views, basically you want to view your data from different perspectives, and these perspectives are typically called dimensions. So for example, if you are looking at sales, right, so the different perspectives could be, or the different dimensions that would apply would be like what is the product that I'm talking about, what is the location, like from which store I'm referring to, and also which day or which time of the day I'm referring to. So these product and store and time, these are three dimensions. So everybody would want to know, get a multidimensional view of the data, right, and of course of the queries, right? So queries could also be like how much of product X I sold from store Y on day Z, something like that. So this is a multidimensional query, right? So multidimensional view and multidimensional queries are central to data warehousing, right? And current and historical decision support information that is hard to access or present in traditional operational systems. So typically, as I told you, that historical data would not be present in the operational system. So if you want to do some analysis with respect to time, right, and your time goes back, say, a couple of years from the present, then this kind of analysis cannot be done in the operational system. Function, right? So that's the second aspect. So missing data. So decision support queries typically require maybe very, very different. And there are lots of problems with this, because if the company wants to know what is the total sales, it has to go to all these different kinds of systems, write say queries or procedures to figure out what is the total sales, and then bring them together, right? So that is what you will do if you want the total sales from all the different kinds of sales systems that you have. In contrast, a data warehouse will have a sales subject area. So let us see what this means. So what this does is that you have a retail sales system, so you have an outlet sales system, and you have a catalog sales system, right? So that is a typical setup in operational systems, where you have three different databases or three different systems, right? But in data warehouse, what you will have is you will bring data from all these systems and put them in a database, right? Or I would not call it database, or a repository. Repository is a better word as of now, right? So I'll bring all the sales data from any number of sales systems that I have, which are typically heterogeneous in nature, right, and put them together in a repository called a data warehouse. So this is how we look at sales, right? So sales subject area. So integrated. So second aspect is integration. So as I told you that these different sales systems may be highly heterogeneous in nature, and you would have very little or no control over these systems, and need to integrate source data. For example, product code should be different, could be different in different systems. So what we do is we try to arrive at a common product code. So there's a product code like iPhone, right, 5S, right, 16 GB. So in one of the systems, its code, or we typically call it the SKU, is different, and in another system it is different. So I would need to reconcile, right, these two things together, right, and arrive at a common product code in the data warehouse. So that's what we do. And another very interesting aspect of a data warehouse is that of a surrogate key. So surrogate key is just in the earlier part of the lecture, I talked about what are intelligent keys. Surrogate keys are just the opposite of intelligent keys. So they are basically meaningless keys. So the keys typically here would be 1, 2, 3, 4, and so on. And when we use such keys, so they do not represent anything, or they do not tell us anything about the record they are representing, right? So that's why they are called surrogate or meaningless keys, right? But these surrogate keys play a very, very important role in data warehousing, as we shall see. Not immediately, but yeah, at a later point of time. So let me clear this. Yeah. Right, and the nature of a data warehouse is typically read-only, or we call it read-mostly. Right. So what read mostly means is that most of the time I'll just read from the data warehouse. I'll not typically write to the data warehouse. When I say write, I mean changing the values, right? And operational systems are typically read and write. Both are allowed, right? So this is the non-volatile nature. And once I say that the data is non-volatile, then that means there are no updates, and if there are no updates, then possibly I don't need any kind of normalization. And that's why I mentioned that the structures in the data warehouse environment are denormalized structures, right? Time variant. So there are two aspects of this. So one is that most analysis that we do would typically have a time component, like you see in this illustration on the right. So I would want to see how my sales are varying with respect to time, right? So here the time is in years, right? So this is what I want to do. I may want to do analysis with respect to daily sales or monthly sales or quarterly sales, whatever, right? So this is one aspect, and for doing this kind of analysis I need historical data. So that is the second aspect. So of time. So it is time variant. So that's what we call as time variant. And now let me give you a brief overview of how this data warehouse looks like. So this is a typical data warehousing architecture, right? So you see on the left, right? So I'll start from the left. So first you look at these operational databases, right? So which are typically owned by the organization, right? So these are the systems which run the business or run the operations in that particular organization. And then we may have we may need data from some external sources as well. So these could be some survey companies which have data about customers, customer demographics, and stuff like that. So they'll also be typically used. And then once we have identified the external and sources and operational databases, I perform what is called as an ETL process, right? So E stands for extract, right? T stands for transformation, and L stands for load, right? I'll talk about refresh later. So I extract. So extract means that I extract only the data that I need in my data warehouse. I do not need all the data that's there in the operational systems in my data warehouse, right? So I choose what data I want, and then I try to typically transform that data, right? Say I carry out certain transformations on the data. Say for example, date formats. So date formats could be totally different if data is coming from India and say from the US, right? So I have to reconcile them and arrive at a common date format, right? And then once the data is ready, I load it into my data warehouse. So data reaches here, right? And then what it does is, so once it is there, right, so it serves a lot of purposes. So it allows me to do analysis, it allows me to do querying and reporting, and it also allows me to do what is called as data mining, right? So a data warehouse is a good source of data for all these different kinds of things that I want to do with the data, right? And at the bottom of the screen you see what are called as data marts, right? And as I told you, on top here you have OLAP servers, so which access the data from the data warehouse and allow users to write SQL queries for the analysis that they want to do. And data marts, here you can see that arrows are pointing downwards, right? So that means these data marts have been derived from the data warehouse, and this is a typical top-down kind of architecture for a data warehouse. We'll also be looking at a bottom-up architecture for a data warehouse, wherein you first build the data marts. So data marts are subsets of data warehouses which are smaller in scope and size, right? And they require less resources. So they are kind of subsets of the data warehouse and easy to build, right? And in that approach, in the bottom approach, we first build these data marts and then kind of integrate them to get the data warehouse, right? So this is the whole process, and you will see that this metadata repository also plays a very important role. I hope all of you understand metadata repository. And on top there is monitoring and administration. So this will come up when we actually talk about the life cycle, right? So the purpose of this architecture at this point of time is that you should know the data flow, right? So data flow happens. So I'll use some other color to illustrate this. Say a red. So basically, once I've identified the sources of data, so these are collectively called a source system, external plus the operational. Then the data is extracted, transformed, and loaded into the data warehouse, and then it serves different kinds of purposes, right? So that's a typical architecture. So I'll end this module or this session with this simple architecture that I talked about. So I basically tried to tell you the typical characteristics of an operational system and that of a data warehouse system, right? And give you some pointers in terms of how they are different in terms of purpose, in terms of their purpose, and in terms of the access to access, in terms of what kind of access or what people do with these two different kinds of systems, right? So in the next class, next session, I'm going to talk about the modeling aspects of a data warehouse. So with that, I end this session.